All right, so we're going to look at graphing systems of linear equations, and this is where you're going to be graphing each line, and you're going to look to see how many solutions there are. So basically, where do the two lines cross? So as you can see here, our two lines we have are in slope-intercept form. So we're going to graph both of these. So this first one, number one, all right, number one, we're going to graph in red. And if we notice, this is a y equals mx plus b form. So our b is a +3. So we're going to go 1, 2, 3, and we're going to start there at b. And then we're going to use our slope, which is 1, and we're going to go up 1 over 1, 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 down 1 over 1, down 1 over, and you're going to keep going. Now, with these, I recommend, especially with the first line, make sure you create your graph so that it covers the whole line. When you're doing this for practices or when you do your assessment to recover your credit, you need to make sure you graph these with a ruler so that it can clearly identify. Graph 2, we're going to use a blue pen, is y equals 2x plus 4. So we're going to go to 4, and we're going to go up 2, right 1, up 2, right 1, up 2, right 1. As you see, we're getting away from the line. So we need to go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. We can kind of stop there because we already see where the intersection is. This is why I use a ruler, because my line is squiggly. But as you can see, we have our one intersection, which is right here. So it has one solution, and that one solution is -1, 2. So the one solution is -1, 2. Okay. So that's that right there. Okay, that's using our XY intercept and identifying our one solution, which is at the point -1, 2. Next, we're going to graph and determine the number of solutions of the next graph. This one, I can't find it. I found the one. So this one, so we have 3x plus 2y equals 10, and we have -2x plus 3y equals 10 as well. So what we're going to do here is, with these aren't fun ones, so we're going to make sure we get them into y equals mx plus b form. So the first one, the top one, number one, we're going to get y by itself. So we're going to subtract 3x, subtract 3x. You get 2y equals -3x plus 10. Now we got to divide everything by 2. And you get y equals -3/2 x plus 5. So we're going to graph that one. We're going to go to 5. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Right. And we're going to draw our line. And then we're going to graph our second equation, number 2. We're going to do the same thing. We're going to add 2x, add 2x. So we get 3y equals 2x plus 5. Divide by 3. Oh, sorry, that's 10. Divide by 3, divide by 3. You get y equals 2/3 x. 10 divided by 3, that's going to be 3 1/3. So we're going to go up to 3 1/3. Draw a point. But this is where things get a little wonky, and we could graph this a little bit of a different way, because this is now I got to go down 2, right 3 from here, and things get weird. If you remember, because this is in standard form, let's start. We can figure out where our x-intercept is. Our x-intercept, we divide everything by -2, divide by -2, and we get x equals -5. So this is going to intercept at x equals -5. And I just realized we graphed the wrong thing. So we're gonna. I have a minus sign on here, and the reason I have a minus sign on here is I was showing another thing on what to do. So for some reason, no, that's right. Oh no, I'm not supposed to have the minus sign. All right, so we're gonna pause this recording. So just disregard what I just recorded. So we're gonna clear this real quick. I'm sorry. I was looking at two different equations at the same time. Don't look at two different equations at the same time. That throws everything off. Okay. Don't look at two different equations. Let's start back over with round one. Round one. Let's graph this one. Number one right here. Okay. So if we're going to graph number one here. Number one, we're going to graph using our x and y intercepts. So we're going to plug 0 in for x. So 3 times 0 plus 2y equals 10. Divide by 2, you get y equals 5. So we're going to plot y equals 5. Then we're going to plug 0 in for y. So we have 3x plus 2 times 0 equals 10. Then we get 3x equals 10. Divide by 3. And we get x equals 3 1/3. X equals 3 1/3. And here we're going to use a straight edge. And we're going to create a line through here, okay? Boom, right there. All right. And now what we're going to do with the second one, so that minus sign is not supposed to be there. So I'm going to take this black pen and make this is supposed to be a positive. Like I said, don't look at two different equations at the same time. It throws you off. So this is equation 2. For number 2, I want to get this into y equals mx plus b form. So we're going to subtract 2x, subtract 2x. We get 3y equals negative 2x plus 10. Divide by 3, divide by 3, divide by 3. Y equals negative 2/3 x plus 3 1/3. So we're going to go up to 3, 3 1/3. Okay. And we're going to go down 2. 1, 2, 1, 2, 3. Okay. We have this weird point right there. All right. Now, if you use a straight edge, you actually see these do intersect at a point, and they intersect at the point 3, 1. The reason I like to use this example here is we're kind of guesstimating. Sometimes it's not good to guesstimate. You can get an exact reason. And the reason graphing isn't always the best thing to use in the world is you run into the points where you do need to kind of guess. And we don't want to always guess. And so we'll learn some more different ways on Monday on how we can use these so that we don't have to guess. All right. So, but this is just graphing in standard form. All right. The last example we're going to do for graphing systems of equations is going to be this one. So we're going to graph the following. These are in slope-intercept form. So 3x plus 4. We're going to go 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Okay, we're going to draw our line. Okay. And then we're going to go down 4. 1, 2, 3, 1. 1, 2, 3, 1. Wait. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And now we have this line. This is line 2. Well, if you notice, these lines are parallel to each other because they have the same slope. They don't intersect ever. So this one has no solution. Okay. So when the lines don't intersect, basically their slopes are the same. They are not going to have a solution. So this is graphing systems of equations. What we're going to look at also here today is we're going to look at graphing systems of linear inequalities. All right, and we're going to just do one of them. So this one, for graphing systems of linear inequalities, it's the same concept. So we're going to graph this one real quick. Might help if I have a pen. Graph number 1. So we go up 2. We go 1, 2, 1, 1, 2, 1, 1, 2, 1. Okay. And if you remember, there's no line underneath. So this is a dashed line. And now we need to figure out our shading. We can use 0, 0 as a test point. So we're going to plug 0 in for y. We're going to plug 0 in for x. 2 times 0 is 0. 0 plus 2 is 2. 0 is smaller than 2. That's true. So we're going to shade this way. I'm not going to do my full shading yet. And I'm going to show you guys why here in a second. Now we're going to graph number 2. So this one would go down 3. We're going to go up 1, left 1, up 1, left 1, up 1, left 1. up one, left one, up one, left one, down one, right one. This has a line underneath, so we are going to draw a solid line. All right. And this one we can again use 0, 0 as a test point. So we plug in 0, 0 is greater than or equal to negative 0 minus 3. Well, you can't really have a negative 0, 0 minus 3. 0 is bigger than or equal to negative 3. It is bigger. So we're going to shade this way. Now, we're going to look to see where do the shadings cross. Well, all the shadings cross right here. Right. So it's all right here. So this is going to be the part that's shading. So that means this whole area is our solution. And then you need to make sure you go through with your eraser, if you did do the little arrows like I did, and you get rid of them. And this is why I don't do the full coloring. I don't like to get rid of a lot of coloring, just a little bit of coloring. Boom. See, this is our solution here. So this is graphing systems of linear inequalities. I do have a practice for you to do after you get done watching this video. Sorry for the mix up on one of the equations. Again, that's why you focus on one problem at a time.